Hello, my name is Rory Coyle. I am the corporate president, and I'd like to introduce my co-founder and co-inventor, Gabriela.
Hello, my name is Gabriela Castro. I'm a co-inventor and co-founder with Roy Court.
And today, Gabriela and I would like to introduce you to an amazing new product, Angel Barrier. Angel Barrier is regular sawdust that's been treated with our exclusive process. This sawdust now is completely fireproof, non-toxic, eco-friendly, and can be made into many different forms and molds. We're going to show you some of the products that Angel Barrier makes. Our number one is Luxagard.
Luxagar does a mold is extremely durable and fireproof. Also, Luxagar can do molding. Right here, one of the moldings. This is Luxagar mixing with fiberglass.
Yes.
Fiberglass. Do you see how you can touch the fiberglass? It's not toxic anymore.
Now, since our Luxagard is completely fireproof, we can actually make fire doors from our product that would completely resist fire for more than 2 hours, made with totally 100% recycled materials. Also, we look here at this sample. Our Luxagard is lightweight, it's durable, it can take a screw, it can also take a nail. It is completely workable. It can be cut and sawn and molded into any shape or form. Now, what we have done is we have tested various other insulating materials, which we're going to show you now that are currently being used. This one you may all be familiar with is insulating foam. Insulating foam has a UL rating, is insect and mold resistant, has been thoroughly tested, and has an Energy Star rating. This particular insulation is used in stucco applications and also for water heaters. It's in many, many homes throughout the world. Another insulating product that we currently use in the world is fiberglass. Fiberglass, as you see, has an R rating of 6.7 and is currently used in attics and crawl spaces to insulate our homes. Now, what we're going to be doing is we're going to subject these materials to certain tests.
And we are going to cover our hands with, we have to use gloves, glasses, and masks to protecting about those products. They are really toxic. And they are in every one of the houses in the United States.
That's true. Yes, we must put on our protective equipment.
Now, let me help you with this.
There we go. All right. Now, I cannot stress enough to not do this at home, as it is extremely dangerous and very, very toxic. There. Sure. Now, Gabriela is going to be breaking off a piece of our insulating foam that we just showed you.
We are going to do the test right here outside because we are going to start to use fire and most of those toxic products. That's why the intention to do everything outside.
Very good. And this is our Bernzomatic torch. So we're now going to subject this insulating foam, which is in almost every home in the world. Wow. Catches fire immediately, has a low melting point, gives off an extremely toxic vapor. You don't want to be anywhere close to this material. Now, we showed you the fiberglass as well. We're going to be testing that in the same manner with the Bernzomatic torch. You can see the fiberglass not handle the blowtorch very well. Very low melting point, very, very toxic vapors. Now we're going to be testing our material, our Luxagard, to the same test.
The only difference right now, we are going to remove the gloves and the mask because this is a green product. It's not for. Also, Rory is going to burning a penny. One penny is going to be the example. You're going to see how is the process. This is the penny.
See, Gabriela has placed the penny directly on our material. One other thing you notice, again, I'm using my bare hands. I have no gloves. And we're going to be subjecting this to the same test we just did with the other materials. Okay, there you go. You have a good look at the penny. Again, my fingers are underneath it.
We're going to take the temperature right now before burning. There's 71, 72, 73 in the
Excellent.
target. Again, until 76.
Perfect. Okay, here we go. Completely molten. As you can see, that penny is completely molten. Again, my hand is directly behind the impingement area of the flame. Gabriela, please take a reading of the surface. And now let's take a reading of the back of the specimen. No heat transfer whatsoever, and our product retains its integrity and is completely solid. This product is going to revolutionize how we protect ourselves from fire. It has an extreme high R rating, it's mold resistant, it's incomparable to any other product, as you can plainly see. It's totally non-toxic. There's no smoke occurrence as well, and it gives off no toxic vapors. And it's made from 100% recycled material that can be used again and again. Now, we have made another test that we'd like to show you today. Gabriela, would you like to explain our next test?
We are going to do examples right here on the bottom. So we are going to burn in to pretend we are in the fires or forest. For example, in California, the last time was 103 houses suffering and pain and burning with fire. Why we do this? We do this because this is important for us. It's an amazing day. We are really excited and happy because we are going to change life. We're going to change the way to care houses, care families, and save life.
Absolutely true, Gabriela. What we've done here, Gabriela and I have set up here, is a forest fire ring. Now, currently, the way they fight fires is they use a ring to burn around the forest to create a dead zone so that the fire cannot continue on to other areas of the forest. As you can see here, we've used our Angel Barrier, which is our recycled sawdust treated, to now create a fire ring. It is non-toxic. It will not harm any of the other plants that are in the area, and there will be no need to burn out any more of the forest. What we're going to do is we have a side-by-side comparison here. And this ring, we used regular, untreated sawdust. Okay, we're going to be lighting up both these fires to show you the containment capabilities of our product.
Okay. We are going to put in enough to turn it off the fire.
Okay, I'm going to wait till go ahead and get that one there as well. Excellent. Thank you, Gabriela. All right, here we go. Okay, we have that one going and started. We're starting this one just after. Okay, you can see that both fires are roaring pretty good.
And we're going to read it.
Again, here's our initial reading. As you can see, the fire now is above 400 degrees, heating up to 580 on this one. And then we're going to check this one here. And this one also is above 480 degrees. Now, here's the interesting point. If you noticed already, on this ring, it's already starting to catch fire on the outer ring. Okay? If you look at ours, there's no fire being caught. And here is also another important point. Look at the temperature of our ring. No more than 100 degrees, 99 over here, and over here, 102. Again, the fire, over 500 degrees and climbing.
Okay, we're going to do the simulation. What is happening in the forest. The leaf, that's the ones take the fire to the another areas, houses, trees.
Now you're going to see that both fires are going to pick up with the kindling, and they're going to grow and get stronger. Now, how they fight fires today is they'll come in with water or other types of retardants and lay them down on the fire to suppress. What we're going to be using is our Angel Barrier, which is our sawdust. And Gabriela, if you don't mind, I'm going to go ahead and put that on there. Thank you. And Gabriela's going to take a temperature reading over here so you can see exactly how much the temperature drops immediately once we put in our Angel barrier. I'm just going to sprinkle a light amount on there. There we go. As you can see, it doesn't require a lot. Automatically, you can see the fire's already going down. Almost completely out. There we are, and the fire is totally out. Very little material needed. And you're going to see that actually the temperature is dropping so fast that it's already past the auto ignition of 451 degrees Fahrenheit, where a fire would automatically start up again. Now, we're going to go and try and relight this fire. I'm going to put some more kindling on there. There we are. As you can see, the kindling is not catching fire. We'll try and reignite it. As you see, it reignites, but it's not sustaining the flame. Only that kindling will catch fire. The rest of the area here will not sustain the fire. And what will happen is this will burn out on its own and not be able to transmit into the other area. Again, as you see, it's almost burned out completely by itself. Here we go. Auto suppression. Okay, now we're going to go ahead and stir all the coals up, but we're going to put a little bit more on there. See, there's still hot coals underneath. So what we're going to do is add a little more of our fire suppressant. Here we are. It's going to go ahead and take everything out. See, the fire is completely out. And here's the amazing point. See, stirring up the coals. What is the temperature reading?
160.
Let's go ahead and show the people.
Can you mix it?
Yep, I'm going to mix it up a little bit more. Stirring up those hot coals. Now watch this. My hand is going to go directly on it. See? Look at that. Picking up the hot coals. Everything. What's wonderful about this is now once they suppress the fire, the firefighters don't have to look behind them. They basically can suppress it and move on to the next area, not having to worry about the coals catching fire again on kindling or anything else. Amazing. Now here's another incredible point. Now I'm going to take this material, I'm going to look over here, and we'll see this is now burned through its ring. It's still going pretty strong. We're going to scoop up this material here.
Over 800.
Over 800. Now see, I'm scooping all this up. We're going to put it up down on top. Look at that. To take the fire right out. It's broken through the ring. So now that means this material is completely, that's fine. This material is completely recyclable. It can be used again and again. Again. It was just how many degrees, Gabriela?
160.
No, how much was it 2 seconds ago?
800.
800.
Over 800.
Look at me. Putting my hands directly on it, holding it. That is amazing. This is going to change the way we fight fires, the way we contain them and suppress them. Now, our Angel barrier can be blown into attics, crawl spaces, can be used to protect roofs from embers that are flying in the wind. This is going to save lives. It's going to protect the firemen. It's going to protect our homes, protect all our lives. My name is Rory Coyle. I look forward to working with you so we could save lives. Gabriela?
Gabriela Castro, co-inventor and co-founder with Rory Coyle. Thank you so much.
Thank you again.
Thank you.